Hi, in this video we're going to look at Unit 5, Day 5, geometric mean. The geometric mean between two numbers is a type of average, right? Because mean means average. But this is a different kind. You're not just adding the numbers together and dividing by how many there are and finding your traditional average. This is a geometric mean, or a geometric average between two numbers. We're going to call those two numbers, for example, A and B. And it's found with a proportion where you take those two numbers, A and B, and you put one as a numerator of one ratio and one is the denominator of the other fraction. And then notice I have the same letter. I know it's real small. Let me zoom in. So then I have the same letter G on a denominator and a numerator of, again, the opposite ratios. Okay, so they're in opposite places on the different ratios, and it's the same number G. That's the geometric mean. And then your two numbers that you're trying to find that geometric average of are the two missing pieces. Okay, so let's look at this first example where it says to find the geometric mean between the two numbers 5 and 45. So again, we're going to set up the proportion, the two equal ratios, and I know that the number that's going to be the same, my geometric mean is going to be in the denominator of one fraction and the numerator on the other fraction. And if you get those backwards, that's completely fine. Okay, so that's where my geometric mean is going to be. I want that geometric average of 5 and 45. So those are my other two sides, 5 and 45. Okay, so now to find G, we're going to do exactly what we've been doing with our proportions. We're going to cross multiply. Now be real careful when it's been a while since we've multiplied variables together. Sometimes we accidentally, because it's been so long, we'll say G times G is 2G, right? But G plus G, 1G plus another G would give me 2G. When I multiply variables that are same together, it affects their exponents, right? G times G is really G squared. Okay, and then 5 times 45, let me type that in my calculator. 5 times 45 is 225. Okay, so then again, it's been a long time since we've had to work with squares and square roots and all of that fun stuff. But to get rid of a square, because I'm trying to find G, the geometric average or the geometric mean between the two numbers, not the G squared. Okay, so to get rid of the square, I have to not divide by 2. Sometimes it's a real common mistake we make. I need to square root to get rid, because squares and square roots cancel each other out. Now if I square root the left side, I have to always also square root the right side. Okay, now because it's a geometric average, in Algebra 2 and in Algebra 2 and in algebraic reasoning, whenever you took a square root, you did the positive and negative, but since it's a geometric mean in geometry, we don't have negative lengths, so we're only going to give the positive value. So when I square root 225, and let me actually show you in your calculator, well, I have an iPhone. If you have an iPhone, this will be what it's going to look like in your iPhone. So I just kind of want to show you. If you don't have a little scientific calculator, or if you don't pull the one up on CMS, okay, so when I look at my calculator, let me zoom out, this is on my phone, let's hope I don't get a phone call or a weird notification. All right, well, I've got this pulled up. So here's my calculator. There's no square root button. It's hard to see, but that's, you know, divide, plus, minus, divide, multiply, minus, plus, and my equals there. And then here I've got to make positive, negative, percent, and then my clear button. So if I want the square root, I'm going to have to take my calculator and I'm going to turn it sideways so that I can see my scientific portion of the calculator. Okay, I want the square root of 225. So I have three options that look like they have square root symbols on them. Let's see if I can zoom in on those. So when I look at these, I can see I have X's inside all of these what look like square root symbols. One has the little 2 there, one has a little 3 there, and one has a little y there. Okay, if I want to square root then I want the one with the little 2. And you have to type in the number you want to square root first. So I'm going to type in that 225, and then I'm going to hit this button right here so that I can square root. And I see that the square root of 225 is 15. Okay, it tells me right there, 15. So the square root of 225 is 15. So that is my geometric mean between 5 and 45. Okay, let's do one more in this video. So my second example says G is 16 is the geometric mean between 8 and which number? So this time they've given me the geometric mean. So that means when I set up my proportion, here equals here, and then remember we're saying the geometric mean goes in the denominator of one side and the numerator of the other side. And this is telling me that 16 is the geometric mean. So that's the one that goes here, okay, between 8 and what number? So that means my other two numbers are 8, and then I don't know what the other one is. And again, I could have put the 8 here. Okay, I don't know what it is, I'm going to call it x. All right, so then I'm going to cross multiply, and I'm going to get 8 times x equals 16 times 16. So 16 times 16, I'm just going to grab my calculator. 16 times 16 is 256. And then I want to divide both sides by 8. My division property of equality. And I get that 1x on the left side equals 256 divided by 8 is 32. Okay? So that is setting up the proportion when you're told to find a geometric mean, or you're told you have a geometric mean and you want to find one of the other numbers. Okay? In the next video, we're going to apply geometric mean to right triangles. We're going to have two theorems. We're going to have a right triangle altitude theorem that uses the geometric mean, and then we're going to have a right triangle leg theorem that uses the geometric mean. Okay, so make sure you come back for that next video to see how to apply this in an actual geometric problem. Okay, thank you so much for watching.